Let's have a look at our pressure fields. Pressure means that a force, a pressure in the fluid, and we have a pressure in the fluid, then a force will act on a surface. This is not really complicated at all, but what is complicated at this point, the complicated part is to calculate the right surface. If the surface is just rectangular, it's quite easy to calculate the square meters, but if the surface is banded, you have to solve an integration for the whole area, or the force over this whole area. And if you have a changing pressure, if the pressure here at position 1 is different to the pressure at position 2, you have to solve this integral over the area, and total force will be different at different positions. This makes it sometimes a bit more difficult to calculate this pressure. When these problems happen, for example, if you are underwater and you go down deeper and deeper, then you have higher pressure if you go to deeper regions under the sea. So now another question. If we look at our property, the pressure, can the pressure be negative? And the answer is no. A pressure can never be negative. You know, temperatures, you know, velocities, they can be negative, but the pressure can never get a negative value. Yeah, if the pressure goes really low in the air or in gas, yeah, you come to vacuum, and if you have a vacuum in a region, then you have the pressure 0, but the pressure cannot never be lower than 0. Sometimes if you make a calculation of a liquid like water or oil, and the pressure goes really down to nearly to 0 and goes under the saturation pressure, then you will also even have a fast change. Yeah, you will also get not negative values of the pressure, even if they should occur because of your calculations. Maybe if you have really high velocities, you can get really low pressures. This can somehow cause values nearly to 0. Okay, so what is a relative pressure? We speak of delta pressure. Delta means differences in pressure. And what is a relative pressure? Relative pressure is just a certain pressure you choose. You say, here is my reference pressure, and everything that is higher is an overpressure, and every value that is lower is an underpressure. And if the pressure goes to 0, you get a vacuum, but you never go below 0. So if you once have made the exercise and you get a negative pressure, the result cannot be realistic or true. Okay, let's have a short look. Now we come to the really interesting point of this lecture. You have learned a lot of state variables, of densities, of temperatures. I think you know all this. I've teach you something about the pressure, but what is now really interesting? What is, for example, fluid dynamic calculation? Yeah? For example, it is the weather forecast. Weather forecast has everything we need in fluid dynamics. We look at the pressure. For example, if you remember a map of Europe from your news. Yeah, for example, this is Europe. Here we have Berlin, we have Moscow, London, Paris, Madrid, Rome. And in many cases, if we look at Europe, we have really high pressure here at this islands, Azoren Islands, and in this region they have always good weather. They have high pressures, and you see here such lines around like circle line. This is called so-called isobaric lines. So on these lines we always have the same pressure. Then we have here also high pressure red region. This H means high pressure here over London, and in most of the cases we have really low pressures here over Iceland. That's more or less the typical weather for Europe. It should be like this: high pressure in the Azoren, low pressure in the cold region near Iceland. And what will happen if you have this situation? Could you imagine? I can tell you what happens. You can't see it really good. We have an arrow here, a white arrow. The air will come from the high pressure region to the low pressure region. It's the same situation as if you have a wheel on your bicycle, on your mountain bike, and you take a pin or nail and make a hole into the wheel. Then what happens? All the air comes from the high pressure region to the low pressure region, and we have wind. And what is happening with this wind? The wind takes all the clouds with them, and then we have good weather here over Europe. That's what we want to have. Okay, so the lines in this weather forecast are so-called isobaric lines. Okay, here I've made a more easy plot. We have continuum mechanics. We have a three-dimensional coordinate system with the coordinates x, y, and z. And we have here these lines. We have here one pressure, we have second pressure, we have third pressure. These are all isobaric lines. And let's say the pressure P1 is higher than the pressure P2, and this is higher than the pressure P3. What will happen in this situation? The wind or the fluid will always flow from the higher region to the lower pressure region. Yeah? The fluid will always go into this direction. So, like if you have a high pressure region here over the Azoren Islands, we have low pressure region over Iceland, and the wind will go from the south to the north. Okay, and how can we describe these gradients? We call it gradients here, this pressure difference, pressure drop, and we describe these gradients by our so-called gradient here. If you have a quantity like velocity or mass or temperature, and on our weather forecast map we have different conditions depending on the coordinate, like x, like z, yeah? And we can make a derivation of these variables for every coordinate. This means gradient. And the short form to write this gradient is the so-called nabla symbol. Yeah? It looks a bit like a delta symbol. It's just turned around, vice versa. And it's really good to use this nabla symbol. And you might wonder, where does it come from? You know, the delta was a Greek letter. It comes from Greek. And this nabla symbol is much older than our delta symbol. It looks the same, just turned around, but it's much older symbol, and it comes from a really old, it was also known in former times, about 4,500 years old picture was found in the city of Ur. City of Ur was near to Iraq, Baghdad, and it shows us a musical instrument like a harp. This instrument was called nabla, and it looks like this symbol. That's where the name comes from. Okay.